Our lesson today is to be able to factor polynomials in the form of, x squared plus bx plus c. Consider the polynomial x squared plus bx plus c, where b and c are integers. To factor this polynomial as x plus b times x plus q, you need to find integers p and q such that p plus q equals b and p times q equals c. I like to use the following um, statement. We want to find factors of c that have a sum or difference of b, right? That's what we're looking for, of b. That's what we're looking for. So here's our key idea. When c is positive, so we're talking about this term here, when c is positive, p and q have the same sign. So when this number is positive, p and q have the same sign. All right. So if c is positive and the middle term is positive, both of these signs in the parentheses are going to be positive. When the c term is positive and this term here is negative, then the sign inside each of the parentheses are going to be negative. Okay? So let's take a look at some examples. We see that c is positive, right? This is our c term. We see that c is positive, and we see that this middle term here is also positive. All right, so that means each of the values are going to be positive. So we factor. X is going to be in the front of the parentheses. We need factors of 16 that have a sum or difference of 10. We know that 8 times 2 is 16. So we have 8, we have 2, and each of these are going to be positive. All right, you check using the distributive property. X squared plus 2x plus 8x is going to be 10x. 8 times 2 is going to be 16. All right, so if we look at these examples quickly, we see that in each of these examples, the c term is positive and the middle term is positive. So when the c term is positive and the middle term is positive, we know that the sign in each of the parentheses are going to be positive. So when I look at problem number 1, all right, there are only two factors of 1, right? 1 and 1, so they're going to go in the back of the parentheses. In the front of the parentheses is going to be x, and because this middle term is positive, each of these signs are going to be positive, right? We could check that with the distributive property. X times x is x squared, plus 1x is that middle term 2x. 1 times 1 gives us a product of 1. We try example 2. All right, we set up our parentheses here, x and x, factors of 8 that we can get a sum of 9. So that's going to be 8 and 1, right? Not the 2 and 4, because 2 and 4 you can't get that sum of 9. And because the middle term is positive, each of these numbers are going to be positive. Problem 3, right? We have our parentheses. We have y in the front of the parentheses. Factors of 8 that have a sum of 6. This time the 4 and the 2 are going to work. And the middle term is going to be positive, or the sign is going to be positive. Check using the distributive property. Y squared plus 2y plus 4y gives us the middle term of 6y. 4 times 2 gives us 8. Then we have problem 4. We need factors of 24 that have a sum or difference of 11. Right? We know that 8 times 3 is 24, so 8 and 3 are going to go in the back of the parentheses. Z is going to go in the front. And because the middle term is positive, means each of those signs are going to be positive as well. All right, so let's take a look at when we have the situation where the c term is positive and the middle term is negative. So when the middle term is negative, it just means that the sign inside the parentheses is also going to be negative. So we still want to do our factors of 12 that have a sum or difference of 8. Going to have x in the front of the parentheses. Your factors of 12, right? 3 times 4 is 12, but you can't make 8 with 3 times 4. We have 2 and 6. 2 times 6 is 12, and we can get 8 with 2 and 6. So we put 2 and 6 in the back. We know that the sign has to be negative in both because that middle term is negative. All right, so let's take a look at these down here. W goes in the front of the parentheses. Factors of 3 that have a sum or difference of 4. Well, there's only 2 factors of 3, 3 and 1. And we know that both of these have to be negative because the middle term is negative. My dog is barking. I asked my daughter to shut him up, and she's not able to do that, I guess. Nobody's paying attention to the dog. So I'll keep going here. N is in the front of the term. We need factors of 35 that have a sum or difference of 12. And we know 7 times 5 is 35. And we know each of these terms have to be negative. All right. X goes in the front of the parentheses. We need factors of 24 that have a sum or difference of 14. 24, we have 12 and 2. 12 and 2. I can make 14 with 12 and 2. Both of those signs are going to be negative, and you should check your answer using the distributive property. All right, now we're going to skip this for now. Let's take a look at the examples when C is negative. Right? When C is negative, it means that the signs inside the parentheses, right, are going to have different signs, right? So we're going to have a plus sign and a minus sign in the parentheses when C is negative. So we come down here. All right, we want to factor this. X is going to be in the front of the parentheses. Factors of 21 that have a difference of 4. Let's say 21, 7 and 3, right? 7 and 3 give us a difference of 4, so 7 and 3. Because the middle term is positive, we need the larger number here to be positive, and you would check that using the distributive property, and you would see that that is going to work. All right, I'm going to erase this here. Just give me some space. We'll do 8 above it. All right, for problem 8, we need factors of 15 that have a difference of 2. 15 is 5 and 3, right? 5 and 3 have a difference of 2, so we're going to have a 5, we're going to have a 3. Because the 2 is positive, it means that this number 5 has to be positive, and that 3 is going to be negative, and we would check that using the distributive property. X times x is s squared, minus 3x plus 5x gives us the 2x. 5 times 3 is 15, positive times negative is negative. All right, problem 9. All right. Y is going to be in the front of the parentheses. Factors of 30 that have a difference of 13. 30 is 15 times 2. Right? So 15 and 2 have a difference of 13. 15 has to be positive. The 2 has to be negative in order for that to be positive 13. And of course, check it using the distributive property. Right? So we have V. We have V. Factors of 20 that have a difference of 1. Looks like that's going to be 5 and 4. 5 is going to have to be positive. That's going to have to be negative. All right, let's check problem 11. Z in the front of the parentheses. Factors of 12 that have a difference of 1. 12 is what? 3 times 4 is 12. Because the Z is negative, the middle term is negative 1. All right, in order to get negative 1, the larger number has to be negative. If you check that using the distributive property, Z squared, negative 4z plus 3z gives us the negative 1z. Positive 3 times negative 4, it's going to give you the negative 12. All right, next one. M is going to be in the front of the parentheses. Factors of 13 that have a factors of 26 that have a difference of 11. 13 times 2 will give you a difference of 11, so that's 13 and 2. That has to be negative, that has to be positive in order for the middle term to be negative. All right, next one. X, factors of 40 that have a difference of 3. What is it? 8 times 5 is 40. 8, 5. This has to be negative, and that has to be positive in order for the middle term to be negative. All right, here's a little summary of what we've talked about. All right, So when C is positive and B is negative, P and Q are both positive. When C is positive and B is negative, P and Q are both negative. And when C is negative, P and Q have different signs. All right, then our last example here says, let me scroll back up. You can also factor some trinomials that have more than one variable. Consider this product. This suggests that a trinomial with two variables may be factorable if the first term includes the square of one variable, the middle term includes both variables, and the last term includes the square of the other variable. So when we look at this trinomial here, notice it meets that criteria. The first term is squared. The second term has both variables. The third term is also the other variable squared. We want to factor it using the same method that we've been using before, except that we have x in the front. We're also going to have y's in the back because we have y squared as a product. Factors of 55 that have a difference of 6. So because this is negative and this is positive, means we're going to have different signs. So 55, what do we have? 5 times 11, right? 5 times 11 is 55. That'll give us a difference of 6. Because the 6 is positive, it looks like the 11 has to be positive, and that would have to be negative. As always, check it using the distributive property. X squared plus 11xy minus 5xy, that's going to give you the 6xy, and 5y times 11y is going to give you negative 55y squared. All right, we'll try this last one. Once again, it meets that criteria. First term is squared. Second term contains both variables. The third term is the other variable squared. So we have m in the front. We have n in the back. And factors of 27 that have a difference of 6. 27. We have 9 times 3 is 27, right? And that would give you a difference of 6. So 9 and 3. This is positive. So that has to be positive, and that has to be negative. All right, so that was a quick lesson. I hope that that's been helpful, and we'll see you soon.